All right, so here we go. Direct variation. The definition. You will see this all the time. It will say the variable y, or it'll just say y varies directly as x. If there is a non-zero constant k such that y equals kx. So the variable y varies directly as x if there is a non-zero constant k such that y equals kx. Now here's the kicker. If you can understand what I'm about to tell you, you'll be able to understand direct variation. For some reason, the math gods thought that it was necessary to use k as their variable, as their constant to represent something, instead of m. K and m are the same thing. This is the same thing as m, which is your slope. For some reason, they want to trick you guys. They said, ha ha ha, I'm going to get those 11th graders at Marshwood High School, and I'm going to make that m now become a k just because I'm talking about direct variation. It's the same thing. This is the same thing as y equals mx plus b. It's just in that case, what is my b? 0. It's not there. It's plus 0. Direct variation is the same thing as a linear equation, except you have to have your y-intercept at 0. It needs to cross through the origin in your graph. Okay?
Direct variation is just a slope-intercept algebraic.
Yes, perfect. Okay? So it's not a new concept. Just now we're thinking about it in a different form. Okay, we're talking about variation. When we get further into the course, we're going to start talking about different types of variations, because not all variations are direct. Sometimes you have joint variations, okay, and you have different types. Inverse variations. We'll get to those later in life. So here's our first example. We want to find the constant of variation k. Same thing as slope. So tell yourself, I want to find the slope. And then I want to write the direct variation equation. Well, that just means find the linear equation. If y varies directly. So all that's telling me is this is direct variation. As x. And y is equal to negative 24, and x is equal to 4. I'm going to show you two ways to do this. I'm going to show you the long way, just so your brain thinks, oh yeah, that's what's happening, and I'll show you the easy way. So if you just want to watch the long way and not write this down. What does my x and y up there look like as a coordinate point? Avery?
4 and negative 24.
4, negative 24. Just watch this, don't write it. Can someone give me a second point? Because remember, to write an equation of a line, we need the slope first and foremost. What's another point that would be on a direct variation graph?
0, 0.
0, 0, right? Because we said the y-intercept is 0. It needs to cross through the origin. So you're always going to have 0, 0. How do I find the slope of those 2 points? Keep going, Avery.
y2 minus 1, so 0 minus 0 plus 20.
Right.
And then over 0 minus 4.
So then we would get 24,
Or negative
4, so we get negative 6. My slope would be that negative 6. What's my y-intercept? 0. So this is your m, this is your b. What's the equation? Y equals negative 6x, right? Does that represent direct variation? Sure. Okay. It's linear. has a y-intercept of 0. How can we do it a little bit quicker? Well, because every single time this is 0, every time this is 0, it doesn't really matter about this 0 in front. Really, what am I doing in direct variation? I'm doing just my y over my x, right? So to find your k, where does that come from? Well, if we start with, and I would write this stuff out, so y equals kx is our form for direct variation. If I had to solve that formula for k, how would I move the x? Divide it out. So my constant of variation, same thing as my slope, is equal to what ratio? Y over x. Same thing as our slope formula, because my second points are 0, which really don't exist. So if I can remember that constant is always y over x, then I can just do y over x. Okay? So my y they give us is negative 24. The x they give us is 4. My k is negative 6. Do we see where it's coming from? Because that origin point is there, we don't really need the zeros. So then let's make our equation again. Y equals negative 6x. So remember, this is the same thing as your slope. So if my slope was negative 6, direct variation tells me that it's going through the origin, so my y-intercept is 0. I don't need it there. Done and done. Questions? No? Feeling okay about that? All right. Could you then use that equation to find a predicted future value? So if I said, well, what's y if x is equal to 10? Negative 60. What would x be if y was negative 30? 5, right? So you could use that equation to solve things backwards if necessary. So you may have to do that. All right. So far, so good. Now let's turn it into a word problem. Good old John is riding his bicycle for exercise. He's traveling at a constant rate, which is important. We need that for it to be linear. Do we truly ride a bike at a constant rate? No, not really. I don't know anybody who does. But we're going to say in this purpose of the problem that he's riding at a constant rate. He's riding 4 miles in about 20 minutes. At this rate, how long would it take John to travel 7 miles? What does this look like as an ordered pair? Is it 4 comma 20 or 20 comma 4? Why is the 4 the x? Yeah, because the number of miles I ride affects the amount of time that I'm traveling, right? Okay, so there's my ordered pair. For x is equal to 4, y is equal to 20. I know, stick with me here. It's hot. Would this be an example of direct variation? If my x was 0, what would my y be? If I traveled 0 miles, what's my time? 0. So is it direct variation? Yes. So to find my constant rate, what am I going to do to find that k? Y over x. 20 divided by 4 is 5. What's the equation? Y equals 5x. Question's asking how long would it take John to travel 7 miles. Is that going in place of x or y? X. So what would our answer be? There we go. So 35 minutes. I know, we're all hot, guys. We're all hot. Long day, block days in the heat. Questions with this? Yes, Sarah.
Could you solve it as like a proportion?
Ooh, that's going to get us to where we are going to go. Sarah asks, can we solve this as a proportion? Sure. What do we know about direct variation? It's proportional. Well, it makes a ratio. And what is a proportion? Two ratios equal to each other. So could we have done 20 over 4 equals x over 7? Sure. Cross multiply and get there. That would also work. Very good. So, look at that. Sarah's like reading my mind. We have something that's called the proportion property of direct variation. Whatever you think. Just want to write the proportion part out. So because direct variation makes a ratio, you can set two ratios equal to each other as long as they're talking about the same constant change, the constant variation. And you can set those equal to each other and cross multiply. We all love to cross multiply. It's like our favorite thing to do. Make those little spooky circles around it. So what the proportion property of direct variation says, again, I can't have zeros in my denominator. That's a no-no in the math world. So that's why that's written there. X of 1 cannot equal 0. X of 2 cannot equal 0. That's just covering our domain. Can't be 0. If you're given 2 points, and they're both on that same direct variation graph, okay, so if I had my graph, oops, that didn't go through the origin. That was bad of me. I had point x1, y1, and point x2, y2. Okay? They should have the same ratio because they fall on the line that has the same slope. That's all this is saying. If this was, let's say, 1, 2, and I went up 1 over 1, so that would put me at 2, 3. Nope, that would not be right, right? 1, 2, go up 1 over 1. No, that would be right. That's not the same, though. Because this isn't 0, 0. Never mind. Up 1 over 2, up 1 over 2 would put me at 2, 4. Gotta make it right. So if these points fall on this graph, are my ratios the same? Is y divided by x the same for both? Yes, that's all this is saying. So if they give you a given point, and they give you one unknown point, you can set up your proportion like Sarah expressed in the last example to solve for an unknown part. Okay? So you can either use, we won't go through that, you can use either method. If you want to solve out your equation first and then plug in your numbers, you may do it that way. Or if you want to set up your proportion, you can set up your proportion. All right, I did not expect you to write all this down. Okay, so let's talk about what we got. We have Sojourner is the name of the first rover that was sent to Mars. Sojourner weighs 24.3 pounds on Earth and is about the size of a child's small wagon. Find the weight of the Sojourner on Mars to the nearest tenth of a pound. Use Newton's law of universal gravitation. So we've got 38 over 100. That represents what? The constant, your k, right? So if that is equal to my k, what would the equation look like? Y equals 8 over 100 x. Okay. So now it says that it weighs 24.3 pounds on Earth. Okay, well the subscript of m stands for Mars. Subscript of E stands for weight on Earth. So if I'm doing it for 24.3 pounds on Earth, is that going to go in, substitute in place for X or Y?
X.
Why is it X, Avery? You're correct.
I don't know. I mean, I'm sure.
What's this ratio?
The y to x.
Remember, constant variation is y over x.
Yeah.
So my weight on Earth is my x. So if we plug this in place of x,
That's your weight on Earth. So.
right, and we want to find it for Mars, right?
Yeah.
Yeah, okay. So 24.3. Handy dandy calculators. Let's do it. Now your calculator does do order of operations. If you were lucky enough to get a TI-84, and some of them have it, some of them don't, so don't get disappointed. I'm going to show you another little trick with the 84.
Yeah.
Does everybody see the alpha button? Hit the alpha button, and then 2 buttons above it, do you see the Y equals button? Did a little menu come up with like an N/V? If you did not, that means your calculator doesn't have it. So alpha,
What is it?
and then the Y equals button. Yeah, yours doesn't have it. If yours does have it and you hit enter, it brings up a fraction bar and it'll allow you to put in fractions. But you don't need that. If I was typing this in my calculator, I would do as follows. I would just type in 38 divided by 100 times 24.3, because your calculator will do order operations for you and work left to right. Math bracket. I guess we don't really need a math bracket because that fraction is not going to tell me anything about weight. What is it as a decimal? Yeah, about 9.2, we'll say 3 pounds. Okay. So that's one way we could do it. How could I set this up as a proportion? Avery.
Do instead of WE on the bottom, put 24.3.
So do 38 over 100 equals y over 24.3.
Yeah.
Yeah, that would get you there too. And then you could just cross multiply it. Okay? All right. Direct variation. Let me see. I'm dying to. We've only been at this for 15 minutes, guys. Cross multiplying, we got that. I think we're good. Do we all remember how to cross multiply? Do I need to do it? I'll just do it quickly in case someone has forgotten. You don't have to put this in your notes. What do I get on this cross product? What do I get on this cross product?
6x.
Yeah, make sure you distribute it. Solve it. Negative x equals negative 2. X is equal to 2. Okay? All right. I know it's hot. I'm going to give you the rest of the time to start working on your homework if you want.